Okay, welcome to a new video. In this video, we shall look at what? Periodicity and model periodic table. We shall look at periodicity and model periodic table. Periodicity and model periodic table. And this is what the model periodic table. The model periodic table has 18 groups. That is what? 18 columns. That means vertical arrangement. 18 groups or 18 columns. Vertical arrangement. And it has 7 periods. That means row. 7 row. That means horizontal arrangement. 7 period. Horizontal arrangement. That means 7 row. 18 groups. That means 18 columns. Take note of that. Let us look at the element in this periodic table. We have elements in group 1. Elements in group 1 are hydrogen, lithium, sodium, potassium, we have rubidium, we have calcium, we have francium. We have beryllium, magnesium, calcium, we have sodium, boron, and radium. We have group 13. Don't forget group 13 can be called 13, can be called 3A, group 14, 14A, 5A, group 16, 6A, group 17, 7A, group 18 you can call it 8A or group 0. Under group 3A or group 13 we have boron, aluminium, we have gallium, indium, thallium. We have group 14. Or you can put neodymium if you want. We have group 14, we have carbon, silicon, germanium, we have arsenic, we have antimony. We have germanium, tin, we have lead, then we have flerovium. Group 15, we have nitrogen, phosphorus, we have arsenic, we have antimony, we have bismuth, we have moscovium. We have oxygen, sulfur, selenium, tellurium, we have polonium, we have livermorium. 17 we have fluorine, bromine, iodine, we have astatine, we have tennessine, helium, neon, argon, we have kraton, xenon, we have random, then we have organism. Then let us look at from group 3 to 12. From group 3 to 12, which are called the transition method. You can also call the group 3B, 4B, 5B, 6B, 7B, 8B, 9B, 10B, 11B, 12B. They are the transition method. We have the scandium, we have yttrium, we have lanthanum, and we have antimony. We have titanium, we have zirconium, we have hafnium, we have vanadium, we have niobium, we have titanium, we have scandium, titanium, vanadium, we have chromium, we have modelidium, we have tungsten, tungsten. We have this one, manganese. We have technetium, we have ruthenium. We have manganese, we have iron, we have osmium, we have cobalt, rhodium, iridium. We have nickel. We have palladium, we have platinum. We have copper, we have zinc. We have under zinc, we have cadmium, mercury. Under copper, we have silver, and gold. Let us stop it. This is the periodic table. From 1 to what? 18 group. Then 7 period. If you count the number of periods, we have 1, 2, 3, 4, 5, 6, 7. Take note. Take note. We have this. Then we shall look at periodicity. What is periodicity? Periodicity. Let us look at this. Periodicity. Periodicity is just what? Repetition or gradual increase or gradual decrease in properties after fixed interval. Take note of that. That's the meaning of periodicity. Periodicity is what? Repetition or gradual increase or gradual decrease in properties of element after fixed what? Interval. That is what? Periodicity. We shall look at what? The periodicity, the characteristics of what? Of some groups in this what? Periodic table. We shall look at the characteristics of what? All these groups in this what? Periodic table. Let us move further. Please, you can pause the video and look at it. You can pause the video and look at this. Okay? I said periodicity is repetition or gradual increase or gradual decrease in properties of elements after fixed what? Interval. After fixed interval. Lesson. This lesson. Take note of this. I want you to know that group 1 element, group 1 metals are called alkali metals. Take note of that. Alkali what? Metals. Take note of that. Group 1 metals are called what? Alkali what? Metals. Take note. Let me be giving you the point. Group 1 metals are called what? Alkali what? Metals. They are soluble in what? Water to form strong base. This one attack water steadily. This one attack water vigorously. Potassium attack water violently. And when they react with water, they liberate what? Hydrogen gas. They are soluble in water to form what? Strong base. They are called what? Alkali metal. Group 2 elements. Group 2 metals. They are called, group 2 metals are called alkaline earth metal. Take note of that. They are called alkaline earth metals. They are called alkaline earth metal. Group 2 metals are called alkaline earth metal. Magnesium, calcium, and coal. They are called what? Alkaline earth metal. Take note of that. Group 15. Group 15. That is group 5A. They are called pnictogen. They are called what? Pnictogen elements. They are called pnictogen elements. Take note of that. Pnictogen elements. Group 15 or group 5A are called pnictogen elements. That is their trivial name. They are called pnictogen elements. Pnictogen elements. Group 6A or group 16. Group 6A or group 16. This one came out in July post UTM or group 6A. This one is 5A. Group 16 or group 6A. They are called Chalcogen elements. They are called Chalcogen elements. They are called Chalcogen. They are called Chalcogen. They are called Chalcogen. Group 6A element or 16 are called Chalcogen. Please pause the video and write them out because I will still rub up the ball. Take note. Those are I'm giving those one that have special name. They have trivial name. They have special name. Group what 1 are called alkali metals. Group 1 metals are called alkali metals. Group 2 alkaline metals. Group 15, that is group 5, are called nitrogen. Group 16, 6A, this one came out in post-UTM UI. They are called chalcogen. Group 17, that means group 7A, they are called halogen family. The halogen, that is the salt former. Group 17, or 7A, they are called what? Halogen. When we get there, I will explain what we mean by we have interhalogen molecule. Interhalogen. I will teach you how interhalogen can be identified, how you can what they can be formed. They are called halogen. That means they can react with each other. Group 17, that means group 7A, they can react with each other to form or interhalogen molecule. Take note. Group 7A or 17 are called what? The halogen family. Group 18, they are called the noble gases. Or you can say inert gases. Inert, because they are less reactive. Inert gases, they are called noble gases. Take note of all those things. Then we have what we call typical elements. Typical elements are elements in period 3. We have breach element, we have typical element. Typical elements are elements in period 3 that shows the real property of their own period. They are elements in what period 3 that show the real property of their own group, rather. They are elements in period 3 that shows the real property of their own group. Take note of that. They are representative elements. You can call them representative elements. They represent the property of their own group. They are always what? Period 3 elements. They are the period 3 elements. They are called typical elements. Let us look at it. Typical elements. Typical elements are elements in period 3. They are in period 3. This is period 1. We only have 2 elements in period 1. Period 1, we only have hydrogen and what? Helium. Those are the only 2 elements in period 1. This is period 2. Period 2, we have lithium, beryllium, and all this one. This is period 2. Then these are period 3 elements. We have sodium, magnesium, we have aluminium, we have silicon, we have phosphorus, sulfur, chlorine. They are known as typical elements. They have fixed oxidation number. They show the oxidation number of their own group. They show the melting and boiling point of their own group. They show the electronegativity of their own group. They show the electron affinity of their own group. They are the representative element that will represent the property of the group they belong. Take note. They show the real property of the group they belong. They can be found in period 3. All the period 3 elements. They are known as what? Typical elements. They show the property of the group they belong. What are those properties? Oxidation state, boiling point, melting point, electronegativity, electron affinity, the density. They are called typical elements. They can be found in period 3 of the periodic table. Let's move further. Let us look at what we mean by diagonal relationship. This one came out in JAMB 2014. It came out in JUPEB 2016. 2017 is there in JUPEB, 2019 is there in JUPEB, 2021 is there in JUPEB. In JAMB, you will always see it. In WAEC, you will always see diagonal relationship. Diagonal relationship. Diagonal relationship. Diagonal relationship. Where you have lithium, sodium, we have beryllium, magnesium, we have boron, aluminium, carbon, silicon, nitrogen, phosphorus. We have it. The diagonal relationship is a relationship between elements in period 2 and element in period 3 of the next group. I repeat myself. The diagonal relationship occurs between element in period 2. This is period 2. And element in what period 3 of the next group. Element in period 2 of the first group and element in period 3 of the second group. Element in period 2 of the first group, element in period 3 of the second group, element in period 2 of the first group, element in period 3 of the second group. It stops here. The diagonal relationship stops here. It does not occur between nitrogen and what? Sulfur. It does not occur between nitrogen and sulfur. It only occurs between what? Lithium and magnesium. Diagonal relationship. It occurs between beryllium and what? Aluminium. Beryllium and aluminium. Beryllium and aluminium. Diagonal relationship. It occurs between what? Boron and silicon. This one is one that came out in 2014. JAMB. Boron and what? Aluminium. They will have similar chemical property. Boron and silicon rather. Boron and what? Silicon. Diagonal relationship. It occurs between carbon and what? Phosphorus. Diagonal relationship. And when you have element with what? Diagonal relationship, the ratio of charge towards size is the same. The ratio of charge towards size is what? The same. That means the atomic radii is the same. Take note, another point. The atomic radii is the same. Element that exhibit diagonal relationship, their atomic what? Radii is what? The same. Their atomic radii is the same. And diagonal relationship occur between element in what? Period 2 and element in what? Period 3 of the next group. Period 2, period 3. Period 2, period 3. Period 2, period 3. Period 2, period 3. Diagonal relationship. Take note of that. Please take note of that. That is diagonal relationship. That means they exhibit, and this element will exhibit the same property. They exhibit the same properties. Element that has diagonal relationship exhibit the same word properties. Let us move forward. Let us move forward. You can pause the video and write it out. You can pause the video and write it out. Pause the video and write it out. Pause the video. Please. Take note. Take note. They can ask you. They can ask you. They can ask you. Listen. They can ask you. The most electropositive element is francium. Francium is the most electropositive element in the periodic table. The most electropositive element is what? Francium. The most electropositive element is francium. While the most electronegative element is what? Fluorine. Fluorine is what? Fluorine, most electronegative element. Most electronegative element. Most electronegative element. Let's move further. Let's move further. Let's move further. To know the atomic number of elements in group 1 and group 18. Let us look at that. To know Have you written this pause video? To know, please, I want you to look at this, listen to this. To know the atomic number of elements in group 1 and 18. We have a special number for that, which is what? 2, 8, 8, 18, 18, 32. It's very special number. Listen to me, very special number. Listen to me. To know the atomic number of element in the periodic table, I have special word number for that. For group 1 and group 18, for this group and this group 8 only, we use this formula: 2, 8, 8, 18, 18, 32. Let us verify. What is the atomic number of hydrogen? 1. Then to know the atomic number of the next element in group 1, to know the atomic number of the next element in group 1, just add what? 2 to it. Let us listen. Please, let us listen. Please, add 2 to it. That means 1 plus 2. That is atomic number of lithium is 3. The next one, add 8 to it. Add 8 to lithium. You have what? You have 11. That is atomic number of sodium. To get atomic number of potassium, add 8 to atomic number of sodium. You have what? 19. To get the atomic number of rubidium, add 18 to what? Atomic number of sodium. That is 19 plus 18. This one gives you what? 7, then 37. You have atomic number of rubidium, 37. To get atomic number of calcium, add 18 again to 37. That means 37 plus 18. What we have? 5. We have 55. Then to get atomic number of francium, add 32 to what? 55. We have 55 plus what? 32, which is 87. Atomic number. That is how to do it. That is a magic number, a special number. To get atomic number of group 1 and group 18, we use what? This special number: 2, 8, 8, 18, 18, 32. Once you have atomic number of hydrogen, you know that is 1. To get atomic number of lithium, add 2 to atomic number of hydrogen. To get atomic number of sodium, add 8. To get atomic number of potassium, add 8. To get atomic number of rubidium, add 18. To get atomic number of calcium, add 18. To get atomic number of francium, add what? Add 32. Then, for me to get this one, group 2. For me to get group 2 atomic number, just add 1 to the lithium. This is selenium. To get atomic number of selenium, add 1 to atomic number of what? Lithium. That will give you what? 4. Atomic number of magnesium, add 1 to this one, 12. Atomic number of calcium, add 1 to potassium, 20. Atomic number of strontium, add 1 to this one, 38. Atomic number of barium, add 1 to atomic number of calcium, 56. To get atomic number of randium, add 1 to atomic number of francium, that is what? 88. Take note of that. Then how can I get atomic number of this group 18 element? The same special number. Let me do it. Special number. Take note. Special number. That means helium. You know that helium atomic number is 2. That means the first element is hydrogen. Helium, 2 atomic number. To get atomic number for neon, just add 2. That means add 2 to helium. That means atomic number of neon will be 4. To get atomic number of argon, add 8 to this. This one will give you what? 2. Add 2. You have add 2 plus 2, 4. You have, I'm coming 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry. That means take away these 2. I'm sorry. Just add 8 to this. You have 10. Atomic number of helium is what? 2. Add 8 to what? Helium. You get atomic number of neon, which is 10. Atomic number of neon, 10. Then add 8 to that of neon. You get atomic number of argon, which is what? 18. Add 18 to that of what? Argon. You get atomic number of what? Krypton, which is what? 36. Add 18 to that of krypton. You get atomic number, and it's 36 plus 18, which will give you 50. We have 54. We have 54. Add what? What we have? Add 32 to this. 32. You get atomic number of what? Of, I'm coming. You have to add 8. Add 8. Add 18. Add 18. You have 54. 55. Then add what? 32. If you add 32 to 54. 32 to 54. You have 86. This one will give you what? 86. Take note of that. Take note of that. The special number for what? The group 8A is what? 8, 18, 32. I won't start from 2. The reason is that because the helium is starting from what? 2. Atomic number of helium is 2. When you get atomic number of helium, which is 2, add 8 to helium, you get what? 10. Neon. Add 8 to neon, you get argon, 18. Add 18 to argon, you get 36. Krypton. Add 18 to krypton, you get 54. Xenon. Then add 32 to xenon, you get random, which is what? 30, which is what? 86. Take note of that. Let us move further. Let us move further. Let us move further. Let us move further. Please let us move further. To know the atomic number, and another thing is this. Don't forget, group 1 element and group 2 element. They are called what? S block element. They are called what? S block element. S block element. Group 3A to group 8A, that is group 13 to group 18. They are called P block element. P block element. These transition metals, transition metals from group 3 toward group 12. From group 3 to group 12, they are called D block element. D block element. D block element. Then while we have lanthanides, our antinines, they are called F block element. F block element. This one can be found in what? Period 6, period 5, period 6 rather, period 6. While this one can be found in period 7. Take note of that. Lanthanide can be found in period 6, while antinide can be found in what? Period 7. Take note of that. You can pause the video and write it down. You can pause the video and write them down. Pause the video and write them down. Pause the video and write them down. And don't forget to what? To subscribe to our YouTube channel. Share the video with your friends. Like, comment. Please don't forget to do that. Please don't forget to do that. We want to give you the best. We love you as you love us. We want to give you the best. We want to give you the best. Don't forget to what? To subscribe to our YouTube channel. Share it with your friend. Comment. Ask questions. If you want to ask questions, you will see a number below, a WhatsApp link. You can punch it and join the WhatsApp group. Take note of that. Take note of that. Let us move further. Let us move further. Hope you we've written this. Please. Let us look at this last thing before we move. Before we move. Let me quickly explain transition letters. And or to know the atomic number. To know atomic number, because of time, to know atomic number of group 13 to 17. To know the atomic number of group 13 to 17. We have a special number for that one too. The special number is for 2, 18, 18, 32. 2, 18, 18, 32. 2, 18, 18, 32. To know from 13 to what? To know this atomic number is what? 2, 18, 18, 32. Let us look at that. Okay, let's move further. Let me quickly explain the atomic number or the meaning of period or the transition letter. I said the transition letters, they are group 3 to group 12. They are group 3 to group 12. They are found from period 4. They start from period 4. And what is transition letter? They are vacant D block, vacant D orbital. They are known as D block element. They have vacant D orbital. The transition letters or transition element, they have vacant D orbital. Look at this for example. Look at iron. Atomic number of iron is 26. Yeah, 26. This is 20 rather, 21, 22, 23, 24, 25, 26. 26. If you draw the atomic or electronic configuration, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then we have 3d what? This is 20, 3d6, that is 26. That is 2 plus 2, 4, 10, 12, 18, 20, 26. And it has atomic number of 26. If you draw 3d, d orbital has how many? This structure has how many orbitals? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. D orbital has how many? This structure has how many orbitals? 5 orbitals. Then few this thing according to Oshu, you have 1, 2, 3, 4, 5. Then 6. It has a vacant D orbital. It's not fully filled. That means transition element, they have vacant D orbital. Their D orbital is not fully filled. Can you see? It has vacant D orbital, it's not fully filled. That means iron is an example of transition element. It's an example of transition element. If you pick, for example, titanium as an example, titanium. Atomic number is 22. Titanium. Atomic number 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d what? 3d2. Then if you draw the 3d structure, in 3d structure we have 5 orbitals. 1, 2, 3, 4, 5. That means 1, 2. You have what? It's not filled. You have D orbital that is what? Vacant. Transition element has D orbital that is what? Vacant. But when you come to this, zinc, cadmium, and mercury, their D orbital is fully filled. This one, their d orbital is what? Fully filled. That is why, take note, JUPEB student, they can ask you, zinc, cadmium, mercury, they are not transition elements. Take note, zinc, cadmium, mercury, they are not transition what? Element, because they have fully filled what? D orbital. They are not transition element. Transition element has what? Vacant D orbital. But for zinc, cadmium, and what? Mercury, they are fully filled. Let us look at that. Let us look at that. If you look at this, zinc is 30. Atomic number of zinc is 30. If I draw the one atomic electronic configuration rather, if you draw the electronic configuration of zinc, look at zinc, atomic number 30. If you draw the electronic configuration, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d10. That means it has 3d10. If I draw it, and I know that d subshell has how many orbital? 5. 1, 2, 3, 4, 5. Fill this one. We have 1, 2, 3, 4, 5. Pair 1, 2, 3, 4, 5. Making 10. It's fully filled. That means for zinc, it's fully filled. That means zinc is not a transition metal. Cadmium, they can ask JUPEB student which of the following is not a transition element. Take note, this one, they have fully filled what? D orbital. Since they have fully filled D orbital, they are not transition what? Element. That means zinc, cadmium, mercury. Then if you have cadmium, we have what? For cadmium, we have 5s2, 4d10. For this one, cadmium, we have 5s2, 4d10. For mercury, you will have what? 6s2, 5d10. 10. That means the d orbital is fully filled. D orbital is fully filled. They are not transition metals. Take note of that. In the next video, we shall discuss the properties of periodic table, which are what? Atomic radius, electronegativity, ionization energy, electron what? Affinity. And we shall look at some, we will take group 1, group 2, group 3A, group 4A, 5A, 6A, 7A, and talk about them, because I will still talk about interhalogen. That is under group 7A, 17. I will talk about interhalogen. Please don't forget to subscribe to our YouTube channel, share this with your friend, call any one of the number on the board. I remain myself, JAMB. God bless you. Properties of characteristic of transition metals. Characteristic of transition metals. They form colored compound. They form colored compound. They form complex compound. Complex, or you can call it coordination compound. Coordination what? Compound. Coordination compound. They are used as catalysts. They can be used as catalysts. Take note. They can be used as catalysts. Take note. These are the word characteristics of what? Transition metals. They can be used as what? Catalysts. Take note. Characteristics of what? Transition metals. They are what? Characteristic or properties. Characteristic of transition metals or transition elements. They form color compound, they form a coordination compound. They can be used as for catalyst. Take note of that. In the next class, we shall move further. Thank you.